Hello, this video is to review applets that are used in Stat 1040 or 1045 at Utah State University. The next applet is the multiple means applet. 51 students in an introductory statistics class were given a sequence of 30 letters to memorize in 20 seconds, and were randomly assigned to 2 different ways of seeing the letters. 25 students were given letters in recognizable 3-letter groupings, and 26 students were given the exact same letters in the same order, but with the groupings that varied in size and had no recognizable chunks. So we're going to go ahead and open up the multiple means applet. And here, we're going to clear out this data. I have data here prepared. And I'm going to go ahead and copy and paste that in. And I'm going to click Use Data. If I had more than one option for a response variable, I'd be able to change it here. And if I had more than one option for an explanatory variable, I'd be able to change it here. We want to make sure that this is recognizable minus not recognizable, because that is what our research question is looking for. So here's my statistic, 3.166. I'm going to show the shuffled options, and we want to do at least 1,000 shuffles. And our hypothesis difference is always going to be that there's no difference in the means. So now we click Shuffle Responses. Our statistic is difference in means, and we're going to go ahead and put our statistic in here. Our simulated p-value is 0.072. The next applet is the correlation and regression applet. Researchers want to see if there's a correlation between the amount of Facebook friends someone has and their brain density. Communicating with friends may increase brain density, whether that communication be through the web or in person. Studies have already shown that having more Facebook friends is positively correlated with having more in-person friends as well. They took a brain scan of 40 randomly sampled students at our university who are active on Facebook. So we're going to go ahead and go to the correlation and regression applet. And this data set is actually just the Facebook one from the applet. So I'm going to go ahead and click Use Data. It highlighted it in green for me. And I can see my sample size is 40. Here's the scatter plot for all 40 of those people. There's a lot of different things that you can do on this applet. Let's click on Show Data Options. You can add any observations that you may want. Let's say somebody had 9 Facebook friends at a brain density of 4. I've now added this point. I could delete this point. I could also just click Revert. I could move observations if I wanted, and then I can just click Revert. Here's how I show my regression line, or the line of best fit. And here's the equation for it. Predicted density equals negative 0.74 plus 0.2009 times your number of friends. Here's how I show the residuals. This is the difference between the predicted and the actual, so actual minus predicted. And when we add all these residuals up, they would cancel each other out sometimes. So we have to square them all, that way we can add them all up. The correlation coefficient is my statistic, so R is 0.366, and R squared, which is just 0.366 squared, is 0.134. I'm going to go ahead and click Show Shuffle Options, and we want to do at least 1,000 shuffles. However, with this applet, it's a little finicky, so I like to do 10,000. It does take a second to load. You want to make sure that your statistic is correlation every single time. Then you're going to put in your R value, so 0.366, and count. Your simulated p-value is 0.0087. The last applet that you're introduced to is the multiple proportions applet. It seems everyone is counting their daily steps. Regular physical activity is important in maintaining and improving physical health. The step volume for an individual is one way to measure total daily activity. Researchers conducted a prospective study over an 11-year period on middle-aged adults to see whether the amount of steps taken was associated with mortality. So I'm going to go ahead and go to my multiple proportions applet. I am going to click this little checkbox, Enter Table, and we have a 2x3 table. And now I'm just going to copy the table into here. Make sure that these are only one word. So we have low, moderate, and high. There we go. And then we have deceased and alive. It may be weird, but deceased is actually a success in this study. So we have 32, 16, and 24. and then 416, 847, and 775. Now we're going to click Use Table, and we are given this graph. Our success is deceased, and we're going to want to change this statistic to chi-squared. Here's your chi-squared. This is your statistic. We're going to go ahead and click Show Shuffle Options, and you want to do at least 1,000 shuffles. And your chi-squared distribution is always going to be skewed, every single time. Now we're going to look and see 25.68, and click Count, and our simulated p-value is 0. If your validity conditions are met, then your theory-based p-value is less than 0.0001. And this is how you use the multiple proportions applet. There's one more applet that's used throughout the entirety of the class, and that is the theory-based inference applet. I'm not going to go into a lot of detail for this applet. However, I will show you how it works in general. So you can change your scenario. You have 4 given options. So if you're working with one proportion, you would input your sample size, and then either your count or your sample p-hat, and the other one will automatically fill. Then you'll do a test of significance, and this is exactly like the one proportions applet. You could also do a confidence interval, and then just click Calculate CI, and then it would just do that for you. Then I'll go to the one mean applet, and it's the exact same deal. I'll do the 2 proportions, and now it's just 2. Make sure that this is the direction of your research question. And then it's the same exact deal. And then same thing with 2 means. Make sure that this is the direction of your research question. And then other than that, it's the same exact deal.